Να ξεκινήσουμε. Όχι, παρακαλώ. Ευχαριστούμε, παιδιά. Είναι οι παρουσιάσεις. Σήμερα έχουμε μεγάλο πρόγραμμα. Δύο παρουσιάσεις συν μόνους. Η επόμενη παρουσίαση είναι από την Κασούρα που θα μας πει τη μόνη που μας φιλοξενεί απόψε. Και μετά θα ακούσουμε τον Δημήτρη Καρακασίλη για... Okay, in English again. Today we have 2 plus 1 presentations. First, who will tell us about Monotech, the company that is hosting our project tonight. And after, we will hear from Dimitris Karakasilis on the CNCF, the Kairos, followed by Dimitris Karakasilis on exploring customer deployment via automotive industry standards. So I'm Kostas. Here we have also my other Kostas. And Dimitra, please come tell us a bit about Monotech.
Thank you very much for the introduction. And thank you very much everyone for being here. We're really excited to host another Kubernetes Meetup. So my name is Dimitra. I am part of the culture team. I'm part of the acquisition for the product roles. So I'm going to take just a couple of minutes of your time to give you a brief about the company, what we are, and what we do. So first of all, Monotech is a technology and consultancy. We are part of the group, and we have presence in various countries. Countries in Europe, and of course outside of Europe, also in Japan. So main focus is in 2 domains. These domains include teaming, that includes cross-functional teams that work together to deliver digital solutions across clients. And the other domain is the strategy. We also support different clients in their business transformation journey. I think I need some support.
Okay, I'll just advance it.
Okay, thank you. So, as we can see here, we have quite a growth in the past 2 years. So starting in month, we were around 50 people, and at the moment, we are close to 100. So we are also allocated in 5 countries that include Greece, Cyprus, and Germany. So these are countries that do have a physical presence, also countries that maybe do not have an account yet. And most of our members are part of the engineering department. In various chapters like DevOps, QA, and application engineering. Of course, the members work quite closely with the delivery and product members to the solutions. As mentioned before, we do have the strategy department with the consultants that support our clients through their transformation journeys. And finally, we have our operations department that support all of the other functions. So here you can see some of our expertise areas. We are a company that is focused on the mobile ecosystem. For example, currently we are building a native mobile application for in Europe for a major player in the automotive industry. And we are also quite focused in data management. Another example of the project that we are working on is the data management platform that captures and processes data from experimental routes of smart vehicles. I think I need some.
Slide?
Yes. Thank you. So here is a sneak peek of our stack that we design on different functions and chapters. And as mentioned before, And you will see the next slide. We are in the growth phase. We continue to grow. So if you're interested, we will be around and we will be happy to talk with you and send more insights about the openings and the projects and what we do. So yes, I don't know what the next step, but that's everything from my side. Thank you once again very much. And we'll get to the presentation.
Thank you. Εδώ στο...
Θα το κάνω μετά. Κάτσε να μου τη χρόνο και να το κάνω στο τέλος.
Θες να το... Α, οκ, οκ. Ξέρω. Έκανα. Όχι. Εσύ.
Καλώς. Βάζετε το screen. Σε 10. Εντάξει, είναι. Okay, hello from me as well. Okay, hi, I'm Dimitris Karakasilis. I work on the Kairos project. It's an OS, single-purpose OS. It's a sandbox project in CNCF. CNCF, for the know that, is a foundation under the Linux Foundation. People don't know that because of Kubernetes, but it was donated recently. And the kernel is a link to the CNCF page with more links to the Kairos project and all. Okay, yeah, take it for if you want. I can share the slides later. So, yeah. Oops. Yeah, that's me. I work for Spectro Cloud, the company that hires the people that are working for Kairos. These are my contact details. I have a profile. And I work from Pyrgos in Greece. So here. I'm on here. Okay, this is the structure of what I'm going to talk about. Just be prepared. What is Kairos in general, the problem that it solves, how it's installed, how you can upgrade, how to customize and build it, projects that try to solve the same problems. More people. Hello. Yeah, what about security? I need a demo if I can switch over to my laptop. Because I forgot I had it on.
Zero?
Πίσω. Yeah, then demo if time allows, and I can switch to my laptop, and then just leave them how to participate and find us and talk to the team. So, what is it? So it is an OS. I said it is an OS. Actually, it is more of a framework. So if you go to the GitHub page of Kairos and the images, you will find articles for Fedora, for Ubuntu, for Debian, Alpine Linux. So the way it works is that we take a distro and convert it to an immutable operating system. It's only used for one purpose. Single purpose OS is the lifecycle. Our goal is mainly Kubernetes, but we have for other purposes with other workloads, like a vol24, for example, one of our users. It's multi-arts as well, the artifacts we produce. It's immutable, which means most of the parts in your file system are not writable, only some parts for user data and configuration. The rest is immutable, which means in some occasions you can actually write files, but this is volatile. After the report. That avoids configuration drift. So you can't just go to one of your Kubernetes nodes, for example, and do something, and the other nodes don't have that configuration. And also it's safe because people can't just get access to the machine, they cannot mutate the operating system. So nothing persists and it's good, and probably they can't even write and change things. Single purpose means it's not a generic OS, it's not for desktop, you can't do multiple. Targeting just one workload, one type of thing. You decide when you begin with, because obviously if you wanted a generic OS, you would need to add packages and put packages and things like that. So single purpose OS. Flexible, what I mean flexible here is it's container based. So upgrades and installation all work with container images, where you can just flash it on a disk. The whole process, your pipelines and everything is containers. I can show that later. Customizable means that although we produce artifacts, so I will show some other projects later that do the same thing, but they produce their own Linux distribution. That's, in our opinion, that's problematic because first of all, you may have your local images, or you have a special kernel or special devices which a distro cannot cover for. But with Kairos, you have a way to either take a Kairos image and extend it with your own things, or start with your own image and convert it to a Kairos OS. And secure, I will not talk about security here because there is more on the next slide. Not anymore.
The pointer needs to be here. Okay.
Yeah, if all of that was mumbling, very easily on any hardware. That's the final goal, but it does that properly. And by properly, I mean there are multiple ways nowadays to create a Kubernetes cluster. Even locally, I mean Docker, you have multiple ways, Minikube kind, whatever you prefer, K3D. But in production, you have special requirements, and Kairos meets those production requirements regarding security and day-to operations and stuff. Okay, now one by one. First of all, we all know or probably are familiar with the experience with hosting providers. So when you go, for example, to Google Cloud and try to create a Kubernetes cluster, you click some buttons. If you're familiar with the UI and all, you get a cluster, right? But when you try to switch to your own data center, actually the experience is not the same. And I'm not only talking about installation, I'm also talking about data operations. How do you upgrade? How do you add nodes? How do you remove nodes? Obviously, it's not as easy as just clicking buttons. So one of the goals of Kairos is to bring it, at least not on par, obviously, because it might better be on par with public cloud. You don't click buttons with data centers, but try to bring some of this experience to data centers, private data centers, and bare metal. Edge computing is another thing with some challenges, some of which are, first of all, when we're talking about edge computing, you have machines on remote locations. That's one of the problems. You may have machines on communication towers, for example. You can't be there all the time, right? You have to be able to update the system and fix the system remotely. And in some other cases, you may have locations with no experts there. Like you don't have an expert on site all the time. So, for example, one case is dentists, for example. It's a real use case. So you have dentists, you can't tell the dentist go USB-C, flash it, plug it in, and do the upgrade. So when we're talking about edge, we have these limitations and also security considerations. Like, for example, we have a Spectro has a customer that is doing Kubernetes on fields for boats collecting fruits, but there's not always someone monitoring those machines, right? You may have your models running there, AI models, your code, your user data. You're not supposed to leave it there unprotected, so you have considerations that you didn't have on your data center, which is protected in a big history. Like I said before, research requirements. So sometimes you need to configure your base rates. You may have, especially nowadays with AI, you may have your own chip or your own drivers for unique hardware. This is not, widely available out there, so you may not get support by every vendor. Or you may even have support contracts with companies. Like, for example, SUSE will send support for X number of machines. You may already have a contract and you want to keep that, which means you want your base rates to maintain that support. Having cloud, for example, let's say you have we are perfectly satisfied with public cloud providers, but then we have some devices unique that you build it yourself for AI devices. We have 10 of them, and you want to add them to your clusters, but you don't want to move the whole thing to your data center. So that's another use case. With Kairos, you can actually combine public cloud machines with your own ones. And the last item here is vendor lock-in. So the moment you invest in one cloud provider, you pretty much you are stuck with that one because the investment is big. Your team learns about the cloud provider, they know the API and all the tools around that. And when the time comes and you want to switch, you may decide that it doesn't worth, the effort and the cost to switch. But perhaps you just invest in something that you can just move to different machines and you do the same thing, all your tooling will be. So the installation, if you want to try that out, this is the link. Actually, you can Starbucks link. You can find the rest there. My demo is exactly that, but if we don't want to do the demo, this is pretty much what you have. Simplest installation differs where you are installing on a cloud machine on your system, but generally speaking, you just download an iPhone, you flash a USB stick, or you put a VM with it. You create some basic configuration, which is cloud init anyway. It's cloud init based, so you create a cloud init file for user you want to enable K3s or not, things like that, and you just start the installation. So if we manage that, also how it works. The upgrade, because I talked about data operations, obviously upgrading the system is one of them. The way Kairos works is the upgrades are atomic, so you get all or nothing. You don't just upgrade packages. You prepare an upgrade image, which is the new version of the OS. You can test it in your lab. You can upload it you upload it on a registry, you contain a registry. And from that, you upgrade. The upgrade works like that. So you have the active ones, which is the currently booted OS. You have the passive ones. The moment you download the new one, which is the transition to this line, it rotates. So the new one becomes the active, the old one becomes the passive, and the system reboots. If it doesn't reboot successfully, it will come back to your one, the passive one. There's also one more image, the recovery one, which is available. It's the first image you use to install. You can explicitly upgrade that as well, or you can assume that this is the image. So you always have a way to log into the system in a tested way. Remember, it's immutable, which means that image never changes. If it booted once, it will go on again. Yeah. And the command to upgrade is this. So you see, this is the URL to a container image. This is a manual way to upgrade. There's another way to Kubernetes itself. What I want to show here is you're upgrading with container images. So your pipelines are building container images and pushing them to container registries. By the way, if anybody has questions, just interrupt me. Don't wait. Yeah.
I understand that you use site previous ones that referring to directly to the system level or it's can you understand the positioning of the Kairos node is actually an instance.
The Kairos node is a machine.
Can you repeat the question?
And these are, yeah, sorry. Yeah. So the question is whether these are actual container images which will be something else, if I understand correct, because they do switch. So the question is, how do they stay container image? So you're not running a container runtime, that's the question. There's no container runtime in the system. They are really able to do this. And they live in a special partition Kairos. So it just pivots to that and it puts. I'm not going to tell you that an image file and partition to this.
So actually when you are, for example, having a file system, you don't need to improve the actual machine, but with fixing file systems, do this.
You don't do that lively, yeah, kind of, but you do reboot. You reboot to the other image. It doesn't lively change the other file. You have the processing memory and such. I'm not sure that would be possible to switch to another OS completely. So it's a bootable OS there. Everything lives in there. The kernel never.
Last question. So, you have this hospital and where containers run and open.
Yeah. So, yeah, good question. So, there is no relation between these containers, the containers that are Kairos images, and Kubernetes. You can do this. I had a user a couple of days back that posted a screenshot of a Linux GNOME desktop Linux on Kairos. So actually no Kubernetes workload at all. And if you go to the releases of Kairos, you will find two types of images, the core ones and the standard. The standard are those that include Kubernetes. The core ones are just vanilla. They have nothing, just the immutability and the ability process and all. So if someone wants to build something on top of Kairos, you take the core images. So it's based on containers, which means that you can work with containers that you are familiar with. You build containers, you push containers, you run containers, but they are written on disk. There's no runtime. There's no Docker run the containers or any other runtime. Okay. Okay, what is important, because I said it's customizable, is that you can actually add packages and configure the system. There are multiple ways to do that, so make sure you visit the pages, customize it. One of the ways is just to use the Earthly. We're using Earthly, if you don't know, that is something like Make, but based on containers, so big process are containers. So it's just by passing some flags to Earthly, this would spit out an ISO. So let's say, for example, you wanted to. Actually, there are two main ways you can configure Kairos. If you start from scratch, you see the system for this. Is there any you could also use Fedora, OpenSUSE, all of them are supported, even Alpine. So let's say two ways to configure Kairos. You can take a Debian derivative in this case, create your own version of Debian and pass it here, and hopefully if you didn't mutate it much, Kairos will build a Kairos flavor out of it. Or you can take what this command produces to the upstream image and just do things on top. For example, in a Docker file, you say from this image, from the image that is produced by this command, actually this produces an ISO, you can say base image there, but from the image this produced, you can say from, then do your things and save that as an image, and that would be a Kairos flavor you can upgrade. Okay? But yeah, make sure you visit the link if you want to see more. Okay, here I'm showing some of the projects that have similar use cases. So single purpose OS targeting containers, mini Kubernetes, most of them. What I'm also here, first of all, I'm saying if you want to look at the competition, but also because you can see that there are big companies working on this, which means there is an actual thing. It's actually used. So, for example, Google they actually use the public cloud. That's how people do Kubernetes nowadays in public cloud. These are open source, by the way. So you can look them up there. While they have similar goals, they're different in many ways. For example, in Kairos, you get a distro. So you don't pick your distro, so you take what they do. Unicode is not exactly it's not exactly containers, it's another thing. So look at that, it's very interesting. But I look for your needs when confident trying to do. So make sure you look them up. And by the way, all these projects collaborate together. We do too. There's a I'm sorry. Skip one. Yeah, there you go. So there is a special purpose working group. We meet together once a month. We present each other's projects. We discuss. We present it in. So this is what happens Kubernetes projects. So what about security? Okay. Okay, we talk about edge, we talk about security. Let's describe it in this way. Maybe uh, at any time, you don't want people to run code on your machines or fix the code you are running or have access to your software. That's very general way to describe security. And without diving into too much detail, the approach Kairos should take. So there are two ways to do Kairos. It's the standard way in which you could have your distance encrypted fully, and there's even more secure way which supports all of that. Full disk encryption. Okay, let me actually explain to you what every item is. So full disk encryption is that my data at rest are not readable. Nobody can read them. They're encrypted at runtime, like you probably have on your laptops right now. Then there is secure boot. If you are familiar with secure boot, that's the same thing Windows uses. So your operating system is signed with some keys, which you enroll to your system. There's a special chip on the system. You enroll those keys. You can delete all others if you want. You want to be super safe. You don't allow anything else to boot on your system. Just a specific set of keys which you have actually. So that makes sure that this system can put anything else other than what you produce. Uh, so this guarantees that Kairos is the only thing that boots. In measured boot is another security measurement, let's say, that while booting, the firmware, the operating system, they calculate hashes of various things and write them to specific registers to which you can bind your decryption to. So let's say, for example, someone manages to enroll new keys on your system, on your firmware, with a specific register which takes the hash of all the enrolled keys, and that means that register value will have changed, and the disk will no longer decrypt because it's found in that specific register. So that makes sure that if there is a change on your system other than the operating system itself, which we said it has to be signed, even outside the operating system, if something changes, the disks don't decrypt, the operating system doesn't boot. All of that together is what we call trusted boot. It's a very interesting topic, and actually, if you visit I had a link here, but if you go to kairos.io/blog, I think the latest blog post, there is a nice blog post, an extended one with explanation of all these things. So this is the more secure way to put Kairos. Just a little more detail. It's based on UKI. UKI is unified kernel images. So there is an image that loads when the system begins, all in memory, and that's all it loads in the Kairos case. That loads UKI image. So your whole operating system is the UKI image. Okay, enough. Okay, I think that is complicated. Yeah, I was supposed to do a demo at this point.
Shall we do?
Okay. Let me switch. If you have any questions, it's a good time.
Yeah, I do have a question. What are you? Is this inspired a bit by what CoreOS was doing in Tectonic in last 10 years ago? 15 years ago? Did you showed a slide with all the other projects?
I think I showed that, yeah. But if I would have to say the main difference, one of the biggest, I mean, they're different in many ways. The main difference is how configured Kairos is. I mean, you build it on your favorite distro. You can't beat that unless you do the same.
Yeah, and you're not.
Είναι ζουμαρισμένο,
Ναι. Εκεί καλά είναι, ναι, ίσως είναι.
Είναι ζουμαρισμένο. Okay. Ωραία. It's hard to see here, so okay. Oops. So I've already downloaded, it's a bit zoomed in so I don't see the whole thing, but anyway, I've already downloaded an ISO. It's based on OpenSUSE Elite 15.5. Standard here means it includes Kubernetes. The architecture generic means it's not targeting any specific device. So if I picked an ARM image, it could be Raspberry Pi here. This is the version of Kairos I'm installing. This is the K3S version included, and that's it. And I also have a config file, which I'm going to show you in a while. So I'm just going to boot this new. Okay, this is going to be hard. I'm going to pick the ISO. Yes, this one. And then I have to say it's OpenSUSE for some reason. Whatever. Let's give it some more RAM to get it finished a bit faster. Is that a 3? It's a 3. A little bit more disk. And then customize and remove this, which doesn't work on my system. And then, okay, I begin the installation. So the flow I'm going to show here is based on a QR code. That's one of the ways. So I'm just going to click enter to save some time. And I'm going to close this. So when this boots, it's going to present me with a QR code. Again, this is one of the ways to install. I could just get a cell and run Kairos agent install, manual install. I'm going to show you my config. This is my config. So this is a cloud minute config, just creating a user, enabling K3S, and rebooting after installation. That's all I'm doing. Actually, these are completely optional, all of them, but I wouldn't get a cell if I didn't have a user. So I'm going to use a tool called Kairos CTL. And I'm going to say register with this config. Right? I wait for the QR code to be on the screen. It's going to pick the QR code. And no, I have to zoom in. It doesn't like it being that small. Maybe I can retry. Maybe I can do this instead. Come on. Oh, shit. That needs to work. It works on my system. Okay, after all, maybe I will have to get a cell. I will get a cell on another TTY. Give me a TTY. All right. So this is the live system. It's not an installed one. I'm just putting from the live CD. It would be nice if I could zoom in here. I can't, but I can zoom in on the left one. Let me know if I'm running out of time, and I will skip things. SSH, oops. Why? And the IP address is 42. Yes. All right. Awesome. Now, let's become root. And I don't think I have the I here. I do. Great. Having better. Okay. Let's create the config. Oops. Zoomed in. And then K3S enabled. True, that's okay. I will skip the reboot, we'll reboot manually. There we are. Okay, there's no typo on the invisible part. We're good to go. So I'm going to run the command manually. Kairos agent manual install. YAML. All is good. So this would have happened if it would successfully scan the QR code, which didn't happen. I think it's the resolution. It happens. I could save the image and try here. It was interesting because you don't have to care much about how to access the system. You just need the QR code and that makes sure it works. So you can just send the image over to someone and scan it. And actually, I think Spectro Cloud even builds on top of that, and you can scan with your phone or something. I'm not sure. By the way, I'm working on the open source team of Spectro Cloud, so this is the open source part. It's not the product of the company. They build the product on top of that. So various things happening. It will copy the images I showed, the AV images on disk. It will some time. What I want to show here is that after reboot, you get a fully working Kubernetes cluster. And this is a K3s one. You can get different kinds of clusters, for example, like KE or your own distro of Kubernetes. And the way it works is Kairos is pluggable. So the Kairos agent here that takes care of the installation at some point gives control to another binary called the provider. That's pluggable. So you can create your own provider. So Kairos agent passes control to the provider. Provider does its thing. For example, in this case, it installs K3s and it gives control back. So the way people build on top is that sometimes either they just create images that are pre-cooked to do one thing, or they create their own provider. So there are providers on GitHub for other distros of Kubernetes. So the default one we include is K3s. And yeah, maybe we could even stop here because it's just gonna give me a cell and I will reboot. So if there are no questions, I don't want to delay the next presentation. Actually, I can switch over to. Okay, I had links to show. Some links to show in the end.
Θες να παρουσιάσεις εσύ κατευθείαν?
Θα μπορούσα. Κλείσουμε εκεί. And now. Yes. Awesome. So this is happening. Okay. If you want to reach out, that's my email. Okay. My personal email, the maintainers mailing list from CNCF. We have a Slack channel, the CNCF one, the channel is Kairos. We still have the Matrix channel because we had it before CNCF and people liked it, so you can find us there, mostly me. And that's it. Thank you for listening and for your patience.
Any questions? Anybody have any questions for Dimitris? No.
I noticed, first of all, just to clarify, the first method that you show passive configuration VM is somehow scanning your screen, this screen.
Yeah.
Okay.
Scanning your screen just for the QR code, but you can actually pass it as an argument. So if you have an image, saved as an image, you can pass the image.
All right. And if say we want to deploy this to 1,000 machines, the plan for automation is via Ansible and manual way.
If you want to do an installation of multiple machines, the first question is how do you get Kairos there, right? I mean, you have a machine with nothing on it. So usually, the first thing you do is you plug the sticks to them. You can manage it remotely after you first get your installation. You can upgrade it through Kubernetes. So if you're familiar with the K3s, the upgrade controller, there is a specific CRD which can actually run things on your system. And that's what Kairos uses. So you can actually apply a YAML, which is a plan, an upgrade plan, and it will run on all your nodes. So it will upgrade all your nodes to a newer image and such. So that's how you do things on many machines. But to begin with, you have to get the first installation in, and usually that needs physical access. Yeah. Unless it's public cloud, of course, where you have remote access. You can automate that. And by the way, that's my machine actually. Where did the other window go? Okay, we lost the VM somewhere. Because I'm full screen. Because it's there. There it is. Okay, if you still have some patience, I will just reboot and I could show you.
Do we have any more questions? If not, then maybe we can go to the next.
Yeah, okay. Thank you.
Thank you again. Yes, now we are ready.
Okay, welcome everyone here in our office in Morotec. My name is Dimitris Karakasilis. I am the DevOps leader of the company, and today we're going to discuss about custom worker nodes in the public cloud environment and through an automotive use case that we have. So, containerization, it's been over a decade that Docker has made this a trend in the industry. But which are the main requirements that we take into consideration while we are thinking about or working on the containerization? These are some of them, but these are all from the user now. So, does this cover everything? It depends, I would say. There are some other requirements derived from either the host system or even the hardware. In this presentation, we're going to focus more on the host system because we'd like to focus more on a kernel specific use case that we have. But there are also other host related requirements like the container runtime that we need to customize most probably, or even security and compliance related things that are derived from internal, company internal requirements. Regarding the hardware related ones, I would say that it's more easy to tackle because we can just switch between the different instance types that are provided in the cloud. Okay. So here in Morotec, we have a close collaboration with a big manufacturer company from the automotive industry. So it's pretty much common for us to work with vehicle data and ingest pipelines. So the vehicle data are actually CAN-bus related data which are ingested from real vehicles. So let's talk a bit about CAN-bus. CAN-bus is a serial communication protocol that it was designed back in 1980s from Bosch. And it was originally designed in order to cover some vehicle-related applications. The concept is that there are ECUs that are interconnected inside the vehicle. They are all connected in the CAN network through a twisted wiring cable. And there is an entry point for all of them through which we can connect and further diagnose the collected, let's say, signals. It is a multi-master, multi-slave, half duplex, and other nice things regarding the lower level, let's say, of it. And what is important here is that it's very common for us to have the necessity to send real-time vehicle data from a CAN interface to another CAN interface, either actual or a virtual one. For the virtual one, let's say that we want, for example, to replay already captured vehicle data from the CANs. So, one way that you can solve this issue is in Linux is to use the socket CAN, which is a user-specific code that we use in order to send and receive messages to a CAN interface, a CAN network interface. On the other hand, we need to have a virtual CAN interface, which is installed through a Linux kernel module. So, okay, this is actually socket CAN is provided by the Linux CAN project. And okay, it seems like a straightforward action to just load this kernel module. So we just spin up an EC2 instance in AWS, for example, and we try to load it. But no, it's not that easy because there is an obstacle here, and the obstacle is that the cloud-flavored kernel, it's not that this kernel module is not just available to be loaded, but it's not even compiled, pre-compiled with the kernel. So we need somehow to take an action, and we need to find a solution first on how to make this available. There are some options. We can either compile the module from its source, we can recompile the cloud kernel itself, or even replace completely the cloud flavored kernel with our own kernel. We're going to proceed with this option in this presentation, and we need also to have a strategy on how to apply it. Of course, in AWS, for example, we can do it through Cloud Init, through the user data, or even we can go with a completely new VM image that we can use in our worker nodes. So we're going to proceed with building the custom cloud image. So we have a couple of options. For the majority of the public cloud providers, there is a standard image builder, either standard, official, or even a recommended one. But there is also Hashtag Packer. So just out of curiosity, how many of you have you heard or even worked with Packer before? Yeah. All right. Okay. So the thing is that first of all, we need to choose the source image that our newly created image will be based. The thing is that there are multiple different operating systems available in cloud providers that we can choose, but there are just a couple of them available at least in the AWS that are EKS based, let's say, what we call as EKS optimized Linux AMIs. This means that the particular images have pre-installed some binaries, so we can leverage this. Otherwise, we will have to build the new image from scratch so as to make it possible to join the cluster directly whenever we spin up a new node, for example. So we're going to stick with Ubuntu because it's a little bit more special, because there are specific tools provided by AWS to customize a bit an EKS-based baked image for the YAML Linux. So here we are. We have already created an image based on an Ubuntu EKS optimized source AMI, and this is the custom one. It is based on Ubuntu 22.04, and the Kubernetes version of it, it's 1.5. So we have just spin up a new EC2 instance based on the custom AMI, just to double check that what we have implemented as part of the Packer installation, Packer build, it's there. We have replaced the kernel, and we have the vCAN module available. We have already loaded the module, and we can see some further information about the module. We are one step ahead, having the actual goal for the fleet, which is to have a worker node using this AMI, the custom one. So there are just a couple of things that we need to do to create a launch template using the custom AMI ID, and to pull the bootstrap script that it is provided and placed already inside the EKS baked image by Ubuntu or Amazon with some special values in order to make it join the cluster once we deploy the current notebook. So this is just an output depicting that the deployed node has the replaced kernel. That was it. Thank you very much. Questions? Yeah.
Thank you for the presentation. It was very descriptive and very helpful for on how to enhance needs of the cloud providers. The question I have is related with the CAN interface. So you said that this interface is used in the automotive industry, and you would like to load this module in a Linux system, right?
Because we want to make it available to the user space, because we are using socket count and all these things, so as to send messages like, for example, we have a use case where we want to replay pre-captured data from the cars.
So are you doing this just for development purposes, for testing?
For development purposes.
For development?
Yeah. Let's say that you have an emulator to emulate, to provide to our end users an emulation platform.
So by enhancing your worker nodes, your Kubernetes Cloud worker nodes, you are actually emulating multiple cars, vehicles.
Exactly.
And you test
Exactly.
this data exchange.
We need to have a network interface, a CAN network interface, which is provided through the kernel module. But in order to do it, we need to customize the kernel itself.
Yeah.
That's the point. So there might be other cases, like for example, we already know that containerd, it's the new standard for the container runtime, but there might be some special cases where the user space requires to have Docker daemon available because the developers have integrated the Docker API. Or even other customizations at the worker level.
Use Kairos.
Yes, indeed. I realized the similarity between the
We can
two. Yeah. By the way, there are other options. I just mentioned Amazon Linux and Ubuntu only, but there is an option for Windows and BottleRocket.
I have a question. In the beginning, you mentioned there were 3 options, and the third one was what you showed, replacing the container, replacing the VM image essentially.
The cloud flavor.
And the first one was, for example, I thought was like building the modules from source. Did you try that and didn't go that way for some reason?
It's just another option. The thing is that I just wanted to share that you can even replace the whole kernel to depict the ability.
Okay. Any other?
Anything out scope of the actual implementation, but you also tried Linux
23. Yeah, there is a discrepancy in the bootstrap process in that 2023. Actually, they have provided the bootstrap process through kubeadm. So you can declare your YAML, and this is passed through Cloud Init. While in the Ubuntu baked images, they keep working with a bootstrap script, which is provided by AWS.
Can you repeat the question?
Yeah. The question is that if I have identified why the 2023 are faster at the boot time? No.
Anyone else know the answer?
Yeah, please.
Is this CAN interface open source?
The CAN, the second CAN?
The module, yeah.
The module, yes.
It's open source.
Yes.
And does it require changes?
It's available to the majority of the well-known distros.
Okay.
It's only the cloud flavor ones that we can have.
So the Kubernetes cluster that you deploy, does it require any changes in the CNI, or you can use any CNI, Calico, whatever? And
through the reason why I mentioned the learn templates, it's because it's the only way to have this custom AMI deployed in a managed notebook. Because it's another, let's say, additional work to maintain a self-managed one. But this is a good point because regarding the update and the life cycle, let's say, of it, because you will need to upgrade the image itself, or even the Kubernetes version. This is quite straightforward, but it's an additional work, of course, it's an overhead. Because you have to update the AMI, create a new image, and then make it available to the cluster. So if there is any other question, I would like just to have a provocative statement, because I already know that there are some people which are enthusiasts of eBPF. I would like to know, or to have your opinion, if eBPF would be something that would solve this issue differently. I don't know. No?
Why?
Because you need, the real necessity here is to access from the user space something to the kernel. Maybe you could achieve something like that through the,
module that you're loading as extra structures, probably you can summarize and do things to eBPF to them. But eBPF is basically like eBPF running, there is eBPF running inside the kernel.
inside the kernel. That's right.
Depends on what the module can do in this case.
Exactly, yes.
You also need the structure of the module, so I don't think 25 of these things.
Yeah, I'm not referring specifically to the module that is missing. I'm referring to the more general, let's say, necessity, which is actually you have a requirement from the user land to access something more specific to the kernel, but you cannot touch the kernel directly. Right now we can do it, we have proved it, but let's say that in the future we cannot do it.
Well, it was a privileged container in a pod. You could probably run eBPF or even mod probe.
Yeah, that's the
Right.
point.
So
I
yeah,
don't know.
like I think maybe the NVIDIA GPU operator does something like this. So when you run the NVIDIA operator on your cluster in order to manage the GPU, the NVIDIA runtime, container runtime, I think it does this. I haven't checked, but it configures the host machine to support different
Okay.
container runtime and everything.
We can discuss it further during the pizza and beer time.
Oh yes. Okay, thank you.
Just,
Sorry. Okay, more questions. Short questions, not because pizza and beer.
Yeah, that is more related to the CAN. I'm not familiar with it. So I'm
Yeah.
just wondering, so you said it's a bus, so it has two ends. One end, I guess it's workloads running in pods, that's why you put it in Kubernetes. You have something running in your pods that has to talk with what is the other end and where is it running.
Actually, there is one case that there is no other end. We just want to replay pre-captured data from the canvas.
Okay, just see if it works. If there was a canvas, if you could just.
Because we want to simulate something.
Okay, there's nothing on the other end.
Yes,
Okay.
there is some option that there is no other end. But we need to have the virtual CAN interface available.
So you're running tests on it.
Yes, there are multiple different cases. Like for example, we give the ability to our end users through a web interface to have some tests, let's say, on top of real data
So
coming from Canvas.
the cluster is accessed by users, not just the test
Yes.
or something. Okay, gotcha. Thanks.
So these users would be developers of ECU software.
Yes, exactly. They
Yes,
want to
so-
test things. They have pre-captured data, so they want to send them
Mm.
over TCP to a virtual CAN interface so as to further process them or give them the ability to process them.
So it's like replaying network traffic
Yep.
over like a
Yep.
tap device or
Yeah, but
something.
the traffic is CAN specific.
Cool. Thank you.
Yeah.